disagrees, we will record the talk, but then once the meeting starts, then we'll stop the recording out. Is that work for everybody?
Sure.
Not that our meeting will be that contentious, but well, good evening, everybody. It is my great pleasure to have more than 25 people tonight, which means that after our talk, we will be able to have quorum for our annual general meeting, the 2021 annual general meeting of the Victoria Centre of the Royal Astronomical Society of Canada. But one of the pleasures of the AGM is we get to have a distinguished speaker. And with all of the talk of doing a light pollution survey in this year and using the sky quality meter, it prompted me to ask Doug Welch, the inventor of this equipment, to give us our keynote speech at our annual general meeting. So, Doug, first of all, I know him because he is brother of a buddy of mine. And I would think in 1982 or somewhere around there, Doug took me up to the telescope on top of the McLennan building at the University of Toronto. And it was fascinating. I thought it was just wonderful. He was showing me how he focuses on this one star and does the photometry, and then he goes right next to it because of the light pollution. He has to subtract the stuff. And it was amazing. But I thought I will never be an astronomer because you got to stay up so late, because I left at midnight or something and you were just starting your evening, Doug. Another thing that impressed me about Doug was he was the expert witness for all sorts of court cases. When somebody would say, I took this corner here and the sun blinded my eyes and I couldn't see the other car coming at me, they would call Doug to work out what the angles were and things. And so it was, he had this kind of magic possibilities, which at the time, I just thought, great, I'm glad that he's a magician. And it's really fun now that I have caught the astronomy bug and I've figured out a bit about what he was doing back then. It all makes sense. Anyway, Doug finished his doctorate at the University of Toronto in '85 and then came here to Victoria. And at least Sid Sidhu and Jim Hesser remember him. I'm wondering if anybody else on the call was around until 1988 in the club. It might be all. It's more than a few days ago. Then after his postdoc here, and I gather he's quite involved with the club at the time. I love it when professional astronomers are part of our amateur club. That really adds a huge amount of value to our game here. Then he went to McMaster and has played many different roles there, and now is provost and dean of graduate studies.
Vice provost and dean.
Vice provost probably means that you have to do a lot of the work without many of the fancy dinners. It's probably something less pleasant, but also very involved with outreach and with the Canada-France-Hawaii telescope and the 30-meter telescope. He is a distinguished member of the Canadian astronomical scene, and it is our delight to have him give the presentation tonight. Doug Welch.
Well, thank you, Randy. And with that introduction, I just can't wait to hear what I have to say. So I do want to first recognize it's great to reconnect with the Victoria Center. And one of the sad things about the pandemic is I haven't been able to get out to DAO quite as often as I used to. It's great to see Jim here and you, Sid. So I'm going to take you on a little bit of a journey, a side journey in my world. And first off, Randy said inventor. I'm the co-inventor of this device, and it's actually my friend, who I'll introduce shortly, who actually does all the work. So we have been working on this project. We released our first sky quality meters in 2005. Still seem to be going strong. So let me just put up my presentation here and we'll get underway. I know I'm the only thing standing between you and the annual general meeting, so you want me to go on as long as possible. So let me just launch this. Okay, are you seeing this now?
Not yet.
We tried this before. Oh, maybe let me just share screen again. How about now?
We're good.
We got it. Well, it's not in presentation mode yet.
We've got them reversed again, Doug. So can you try and switch them the other way around again?
Okay.
Yes, that's right.
Okay, very good. So first off, let me go to the next slide. And before introducing Anthony TEKATCH, you might, like what we're measuring basically is light pollution. Ideally, we'd be only measuring the night sky brightness, and there are places you can actually do that. But I wanted to introduce what light pollution looks like in a spectral form. This is a picture I took myself in the early 2000s at Hamilton Harbor with one of those cheap plastic ratings over the front of one of the recently released new digital cameras. So we're looking across the harbor toward where the steel mills are. And so it's like a slitless spectrum because they're all lined up on the horizon. And what you're seeing mainly are the spectra of high pressure sodium lights. That's the dominant set. And you can see how choppy they are. This is nothing like a continuum spectrum at all. There are a handful of mercury vapor lamps. There's some right near the middle there where they just have three or four spectral lines. And then there are one or two actual flames in this, and they're the continuous spectra. They tend to poke out more at the red end there. So if we're seeing light scattered from light polluting elements, these are the things we're seeing. And if you're looking at a moonlit sky, it'll be very continuum, a lot of blue scattering. If you're looking at more recent set of spectra, which I haven't taken yet, I should go do that. There'd be more LEDs, and there'd be a bigger blue shoulder in those, and be more like a continuum, but than these were. So here's Anthony. Anthony lives in Grimsby. Anthony's extremely good friend, and we've been sort of hanging out together, making things since the early 2000s. We were inspired by the work in the 1970s of Richard Berry and Rob Pike, who put together a device for measuring the brightness of the night sky. It was based on a flashlight lamp and a linear gradient filter. And they did some mapping of the light pollution around Toronto. it became clear in the early 2000s that there were sensors that were just kind of ideal for this. They weren't photomultiplier tubes. You didn't need high voltage. You know, you needed to only give them 5 volts. And the sensor we used actually is a voltage to frequency converter. So Anthony and I put together a design for that. One of the great things about this device it's so sensitive, it goes very, you know, the frequency becomes very low, but it's very linear. And so we built the meter around this sensor. And there are 2 regimes, one where we're counting how many pulses it produces a second, when that's the most precise thing to do. And when the pulses get slower, we measure the time between the edges, and that gives the high precision. So Anthony's the person that actually puts these boards together and puts the whole units together, calibrates them. He also has coded this amazing piece of free software called the Unihedron Device Manager that can plot up all your readings, temperatures. It can control mounts. If you want to put your meter on a modern mount, it can point it around the sky, and it's just an amazing piece of software. He's also designed and put together a whole bunch of 3D printed accessories that make the meter do things you'd like it to do, and he provides a huge amount of support. So he's the main person that you interact with respect to the sky quality meter. So here's the very first model that we produced way back in 2005. We call this the classic model. If you look on the screen at the front there, you'll see a little blue dot off to the right. That is where the sensor is. The blue is an infrared limiting filter. So it turns out that for raw silicon, which is what the sensor is, the actual red edge is a little dependent on temperature. So if you cut it off right before that, you basically do away with that temperature sensitivity and wavelength. Under a very dark night sky, most of the light is actually coming from the hydroxyl bands at the red end. So having that, having a little variation in the bandpass at the red side is not a good thing. So that filter keeps it constant. So as you can see, you might get the wrong idea about this box with the red button on top. So we don't encourage you to carry this onto planes. So our next and most popular handheld model is this one. This time the display is on the side. In the previous one, all you had to do to take a reading, you push the button, it records, it records the night sky. And as soon as the measurement is made, then it turns on the display. This works the same way, except now the display is on the side, so you don't have to look at the end of the display anymore. And the measurement is in magnitudes per square arc second, something that confuses everybody, even astronomers. But it is a very nice compact way, a logarithmic way to express the surface brightness of the night sky. In this case, we have a membrane start button, so it's not nearly as dangerous looking as the SM Classic. And you can see there's a lens on the front there that it's not a real lens, it's sort of a plastic lens that's used in flashlights. What it does is have the effect of limiting the cone much more than it's more full width half maximum is about 20 degrees on either side of where you're pointing it. Whereas the classic was the acceptance angle was much larger. So we have a variety of these different models that are used for different reasons. This one is connected. This has a USB connection to it. So in this case, the previous two models, they were battery powered. This one runs off of the USB input. And obviously it doesn't have a display. Use your computer or whatever it is you're connecting to take the readings. There are all sorts of ways to take the readings. There's a straightforward set of serial commands that you can listen to, but the unihedron device manager also will take readings and plot them up and do all sorts of things with them. So the fact that it's connected to a computer means that you can do things like light pollution surveys. And if you attach a GPS to your computer at the same time and drive around, and I'll show you an example of that later on. This is a version that doesn't look dramatically different. It's not in a lot of ways, has the same sort of light collecting lens-like thing. But in this case, there's a double EEPROM inside that will record readings. And it can be battery powered and basically take 5-minute readings every 5 minutes for about a month before it needs to have the batteries changed. And we also offer a solar powered version with nickel metal hydride that'll go many, many months as long as you don't have snow piling up on your solar panel. So this is this is something that people use when they want to monitor a site that's remote from anything. Currently, you actually have to go out and visit the meter to read the material off and reset it. Obviously, you need to change the batteries, so you can do those things at the same time. On the other hand, we have the Ethernet version, which actually is powered. It can be powered directly from an AC adapter. You can also power it by power over an Ethernet connection. This uses plenty of power, so it has the benefit of staying warm. And if you put it inside what do you call it, an enclosure, it's warm enough that it'll tend to keep the dew off the glass plate on top. And that's a good thing. It can dry out rain. It can melt off snow slowly. At the same time, birds tend to find it very attractive as a warm place to sit in the winter. So when you see dropouts in your flux, that's often the reason with this meter. I'll just show you in a minute, because this is programmed. You can take readings as often as you want, continuously. It is possible to use this model as a cloud monitor. And here's an example of doing that. So we have magnitudes per square arc second on the left-hand axis. The red trace is the readout from the meter. You can see I'll talk about the green trace in just a minute. The readings saturate but a little after sunset, a little before sunrise. Has a huge dynamic range, but not that huge. So you can see that mainly that red trace is pretty smooth. It doesn't vary much from time to time. So if you have any amount of light pollution, passing clouds will tend to create variation in the sky surface brightness. And so if there are clouds, it'll be choppy, like the rough diagram over here, and it'll be more smooth if it's mainly clear. So we basically produced a figure of merit we call the clear sky factor. Measures the smoothness of a series of these measurements, and when it's relatively smooth, it means it's probably clear. And when it's varying a lot, then it's cloudy. So I have a website if anybody's interested where I can forward you the set of examples of graphs taken over a series of nights to show you the variation. But it's excellent as a cloud sensor, and anywhere that there's actually some degree of light pollution. There are also these 3D printed parts. What you're seeing on the left here is a filter adapter. There are two different sizes of filter adapters where you can take the filters from that you buy for your standard eyepieces and put them in front of the window of the sky quality meter if you want to restrict the wavelength range to a certain amount. And so it's just, you replace two screws on the meter, put this over, and off you go. On the right, there is a tripod adapter where you can basically do the same thing, and the meter will be pointed directly overhead, and you can attach it to a tripod wherever you like. So we have a number of things like these. I'll show you a window mount for a car later on. This has been used in all sorts of ways we didn't actually anticipate. We've been very happy with how broadly it's been used around the world. Way more than 10,000 of these things are out there now in all their different forms. And there are various groups who have networks that collect data from their units all over the place and store them in the database. It's been used by the Globe at Night program to help educate people about light pollution and introduce people to helping to preserve the night sky. This particular article was one in which an atlas was made of the night sky, artificial illumination of the night sky all over the world. So it used satellite mapping at night to measure the light that actually got out to the satellites. And the main source of ground truth for what the light pollution was on the ground came from the sky quality meters. There were a couple of other things too, but in terms of the number of places where people had sky quality meters, they were by far the most abundant, well-distributed set of meters. And of course, it'll be interesting to revisit this in a couple of years to see the differences that time has made. Basically, it's not entirely, we used to push low pressure sodium because it was cheaper than incandescent. Well, it turns out that LED is cheaper than everything, and it's way more light polluting because the amount of blue light that is generated. So there have been many groups who've done their own studies. There are a whole bunch of papers in refereed journals and also non-refereed. These folks at the US National Park Service did an extensive study with us, and they produced this slide deck from a light pollution meeting at MOMEG Antique back in 2015, where we worked with them to sort of put together, they wanted to do calibrations in a certain way, and we helped them understand how to go about that and use our different models. So there have been unexpected uses of the sky quality meter. I think the one I love most is a whole sector of sea turtle researchers and companies. It turns out our meter is by far the best value for low light measurement. And so there have been instances where hotels or commercial entities near sea turtle hatcheries have actually been using our meters to show that they're not introducing significant additional light. There have been mining companies that have set up near these sea turtle hatcheries, and they have also, in their contracts to keep too much light trespass from affecting these beaches, they've used the meters to demonstrate that they're meeting the standards of the agreement. There have been a number of places. The U.S. National Park Service is one where they want to document every aspect of their park, the sound field, the light field, the ecology, etc. And so they've used these, mainly the data loggers set up around their locations to track how things are changing with time. One of the things that's had increasing popularity in recent years is people wanting to take their sky quality meters for a ride and to measure not only what it's like at a given site, but to drive around a large area under the same conditions over the course of a few hours and make measurements. And in the lower left here, you can see a window-mounted sky quality meter with its USB cable going into a laptop. There's also a GPS USB module connected to the same laptop, and the UDM software I was talking about collects the readings as they go, and even allows you to take notes. On the right here is a region where there's been mapping. If you blew this up, you could see those little markers are each magnitude per square arc second, and they're color coded. Near the intersection, it's brighter. As you get further away, it's darker. And this is a great way to sort of map out the areas in a national park are a much wider area, and it's very straightforward with the SQM-LU and basically any GPS module that will read out in the usual sentences. And this is by Bill McKeague, who's associated with IDA and a couple of other Western organizations. So, and Randy wanted me to keep this short so I could take some questions. And I could talk to you for hours for various aspects of this, but I think it would make sense to ask you what you'd like to know more about. And if you want to follow up, there's the web address that you can do so. There's a lot of material there. It's a website right out of the 90s, but does the job. So let me just stop there.
Well, thank you very, very much. And great. I was hoping David would start the questioning.
Oh, hi, Doug.
Can you give background with how we've used the SQM so far?
Yeah, I can mention that. This is an idea we had that I guess Sid and I sort of spawned this in 2010, and we just took a team of people. We took Sid, do you remember the exact number of people? Was it like 10 or 15 people?
About 10 teams with the 2 in each team.
All right. So
yeah.
we went. They went out in separate cars, and I think Sid did the original mapping. He actually took a map and sort of split up into different areas, and we were sent to different locations. I guess there were like addresses, weren't they, Sid?
Yeah, that's correct.
Yeah, and they took the readings there.
Yeah. So we gave them a precise location where they need to stand and take the measurement. So that's what, at least then we could put it on the map where this readings was taken.
Right. So basically we had a set of points over the lower part of Vancouver Island, or just around Victoria. I think we went out to Sauk and Sydney as well.
Yeah, that's correct.
And we tried to do them under a certain number of nights that were close together. In actual fact, because we couldn't get all the ground done, we waited till the next month in a similar lunation, a similar phase of the moon, and we went out again. So basically, we ended up with lat-long coordinates and readings from the SQM meter. And I took an open source GIS program called QGIS out of Germany.
Yeah.
And Doug, I'm sure you've heard of that.
Yeah.
So I basically just took that and fed the points into QGIS and actually plotted the points. I also took a scale which was based on Sky and Telescope's scale, and I took that and I color coded the dots. So that's basically what we did to date.
Yeah, no, and that's a lot like what that survey I just showed you did. You know, those lat-long points and the value are basically, what is it, a KML set of data, and you can, you know, take those, plot them, smooth them.
Yeah,
so,
you could certainly use Google Earth now, I guess.
Right.
We didn't have that at the time,
Right.
but yeah, there's lots of different ways of showing and depicting that now.
Yeah.
But I did have a question for you, Doug.
Yeah.
I know that there's a kind of an interface to the product. So there's a couple of questions. Because that interface exists, and because the device can be a USB device, I actually have one of those USB models. Does that mean that I could probably attach this to a Raspberry Pi if I wanted to?
yes,
And then
absolutely.
could I run like Python code or something?
Yes,
to
and
interface?
there is sample Python code that is available on the website, and we used to send out a CD. Now we send out a USB key instead, but it's on there. It's not necessarily Python 3 yet, but it's really straightforward to modify.
Well, that's excellent.
There's examples of Perl. There's Sky. You know, there are products you can buy like Nightwear, SQM.
Yeah.
So
I really like the UDM device manager that Anthony wrote, because I actually use that on the laptop with a GPS puck, and I can drive around. I can probably get readings that way, and I get constant GPS feed, which gives me the time signal as well.
exactly. Yeah, and it's just an amazing piece of software, and that is entirely Anthony's doing.
Well, it's actually, I applaud him on that. Now, the very last question I have is, would you be willing to sort of informally kind of consult with us when we do our next survey?
Oh, sure, of course.
Oh,
Yeah.
excellent. Thank you.
Good news. Gary,
Thanks, Doug. That was fascinating. First of all, congratulations on being an entrepreneur and having thousands of these things out there. Like, wow, that's impressive. Couple things. This thing is rainproof. Can I point it at the sky and get it rained on here, and it's not going to die on me?
Well, it's low voltage. I wouldn't say it's rainproof. So we do have an enclosure that is more weather resistant. You know, if you want to make something absolutely weather tight, it's extremely hard. So
that's
we
what I
basically,
thought.
yeah, we have the enclosure itself with the SQM LE that'll generally keep things dry because it tends to be warm. The data logger doesn't produce enough energy to sort of dry things out. So you need to make sure the hole is fairly open at the bottom and hope you don't have too much insect activity.
So does the glass, I'm assuming it's a clear glass front, does that alter the reading at all?
It does, but it's easily calibrated, and it tends to be 10 or 11% almost.
So you can calibrate that out.
Yeah.
And is there any benefit of strapping one of these things to your scope while you're observing, just to see what the reading is while you're imaging?
You know, you could make use of that to determine what your sky background is going to do, but you don't want to get too close to the horizon, because then you start including things that you know, aren't sky in front of you. So
Okay, good. Thank you very much.
Really good. Leslie Welch.
Hi, Doug. I bought one of your original SQM meters, I think in 2006, when you were at Starfest.
Yeah,
And one of the
thank
things
you for that, by the way.
did that encourage you? Good. One of the things that interests me is the intercomparability of the original couple of versions of the sky quality meter with later versions. And in particular, there may be electronic or other sensor variations, but in particular, because of the cone, the size of the cone. And I wonder if you could comment about that.
Yeah, so we have an integrating sphere we use to calibrate these. And if it's a decent integrating sphere, it shouldn't matter basically how wide the cone is, because you get the same surface brightness in either case. And we calibrate both against a meter that is NIST traceable in terms of 0 point. So there is an assumption that's built in basically to how the brightness of the sky will fall off with angle. If you had unusual circumstances where it falls off in a different way, that might give you different readings for the wide angle and the narrow angle. But to first order, it's a pretty good comparison. They're centrally weighted. It's enough sky that it really does average out a lot of the variation you get over that cone. At a dark site, the main factor is when the Milky Way will go through your cone. That will tend to vary the baseline by, well, in the southern hemisphere, it might be a couple of tenths of magnitude square arc second when the center of the Milky Way goes through, but here in the north, it's not that big an effect. It tends to be more like 10%.
Just one comment. I'm almost appalled that there are 10,000 of them, because when I bought it from you, I thought, my God, this is the most nerdy device that could ever be invented. And now it's almost common. So it's a bit disappointing.
As a nerd, it turns out you're not alone.
Sid Sadu.
Well, Doug, it's a great presentation. Thank you for coming here virtually. My question is regarding drive around. What's the sensitivity? Like say if I go 60K an hour versus 10K an hour, how quick the sensor picks up the reading?
So it depends how dark the site is, but I would say you should stop if at all possible and turn off your headlights.
Okay.
Yeah, just take out that possible variation in terms of what's around you. So, and we don't encourage you to operate it while driving.
Well, let's just say it's all automatic. You simply drive around as long as you don't drink and drive.
Well, yeah, you could make it automatic. It's fairly straightforward to do that. But the way that I think the default configuration is you have to push a button to take a reading.
Okay, that's right. Yeah.
Yeah. So then it records at that time for that spot. So.
Because if you push the button, but you're still driving, so you have maybe 100 meters by the time the meter register the readings, and it may pollute the actual true reading.
Yeah, the thing, I don't really have much of a sense of this. It's certainly the case that most silicon diodes are somewhat microphonic. So that if you hit them, that will also produce a signal. So I think stopping your car is probably a good idea from that point.
Okay. Mm-hmm. Thank you.
Sure.
And I would think the headlights are the killer. Jim Hesser.
Doug, you in your very nice presentation, you mentioned systematic surveys by the U.S. National Park Service. Are you aware of similar activities in Canada?
I think there are several such activities, but going through my email today, I wasn't actually able to refresh my memory. I do know that they're often used to attempt to qualify for dark sky preserve. They're a very simple way to get the readings you need to see if you're even in the ballpark.
Thank you.
My question, Doug, please explain the units, magnitudes per square second. Practically, what does it mean with the different Bortle numbers? Like,
well,
what are the, for people who are urban astronomers, like most of us are, what are the numbers meaning?
So it is a surface brightness measurement, and it's a logarithmic surface brightness measurement. So it's a way to capture in a small number of numbers, basically a large range in brightness. It is how much light is coming from a cone, basically. And ultimately the magnitude scale is tied to vega. But magnitudes are one of the great embarrassments of modern astronomy to science. I mean, we would never use this way. We would never invent it now. I mean, our excuse goes back to Ptolemy's catalogs and Hipparchus in terms of the numbers they were using, and somehow we wanted to jam in whatever we did in the future back to those numerical ratings of how bright stars were. So just to put it in context, the very, very darkest skies you'll get anywhere are about 22 magnitudes per square arc second. As I said, ours saturates at something like 6 magnitudes per square arc second. That's a ton of dynamic range, but it doesn't get up to daytime. So if you wanted to do an even broader range, you'd have to put a neutral density filter on. You also asked about the Bortle scale. Sky brightness and Bortle scale are actually two different things. They're not unrelated to each other, but the Bortle scale has a lot to do with transparency. So it's a combination of dark sky and transparency. So that you can get a dark reading, in a hazy situation if there isn't light pollution nearby. So, a fog will give you a reading that is dark, even though you can't see any stars. So they're not directly comparable. There is a pretty good relationship between the two, but Bortle scale is not technically linear. It kind of goes back to the same Hipparchus, Ptolemy numbers when you get down to it.
Well, thank you. That was really good. Oliver.
Thanks. I'm sorry about the wrong hand here or there. Doug, excellent talk and stuff that I, as a real amateur, didn't know anything about. I'd be interested to know what the results have been. You talk about the U.S. Park Service and so on making use of it. Has your creature had any effect on light pollution in cities, in parks? Has it been useful?
So I think that's an excellent question, and I'm not sure I'm the right person to ask. I do know that we hear about the occasional success story where people have used this and argued. I think it was Cherry Hill. No, it's not Cherry Hill, Cherry Park Preserve. There are certain areas where they've been used to sort of say, this is a really dark spot, and darkest place in the, surrounding 300, 500 kilometers, we should make an effort to keep it dark. So we hear a couple of those stories. I think its use, there are a number of places it's been used in Europe as well. Has it repelled light pollution? Probably not. But it may have been effective in slowing it in certain places and affecting attitudes. So it's an excellent question, and I really don't know the answer.
Okay, that means it's really good. Right.
Okay,
Thank
I
you.
would love Dorothy to bring up her comment about the Milky Way, and then we'll bookend this part of the evening with David Leaf with a final question. So Dorothy?
Good. Am I on? Can you hear me?
Yeah.
Yep.
Yeah, okay. So I've heard of some, or read a few years ago, that a study was underway to compare the brightness of the milk in a dark site, of course, 22. The brightness of the Milky Way versus of out of the galaxy, few stars. Do you know anything about how that's transpired and what the difference would be? That would be useful and fun to know for when one was lucky enough to get to a really dark site.
So I don't know the answer to your question. I would say that the contribution of the Milky Way is a constant, and the surface brightness due to light pollution transparency is not a constant.
Yeah, how
So,
true.
you would have to have very, very similar situations to be able to compare those things.
It's interesting to know if you're observing from such a site and trying to distinguish faint objects that are closer in the Milky Way versus outside. Just thank you. Just one comment about the use of the sky quality meters. A few years, must be 4 or 5 years ago now, I talked to an Oregon state park ranger who was at the Oregon Star Party, and who told me that it was he and a couple others in the particular park, which is southeast of Portland, don't remember the name, were using it and had identified particular places that were good to take to direct tourists to, and they were highlighting these are places where you can actually see the sky better from our park than over here by the parking lot. And so that educational aspect, even though it may not be really big news gathering, is certainly helping to spread the word to people who go to parks anyway.
We have had a lot of interactions with the folks in Oregon, so I'm glad to hear that.
Good.
And if you go to the Unihedron website and poke around, you'll see there are all sorts of papers and newsletters, and you can probably find some of the Oregon material there. There's well over 100 publications which have used it, including some PhD theses.
Cool. David, you get the last word.
Yeah, Randy, I'd actually like to defer to Bill. I know that Bill had his hand up.
Oh,
No, it's okay.
Are you sure? Okay, so my only question, Doug, and I'll probably have to take you offline with this anyways, is ideas about normalizing data subject to sky conditions. But we can take that offline.
Okay, sounds good.
Okay, and thank you very much.
Okay.
Well, I want to thank you so much, Doug. I'm a Facebook friend of yours, and every once in a while you come out with just a spectacular post. I remember before the second data release from Gaia came out, you did this wonderful review, just text about how this is going to resolve, or at least potentially resolve, great questions of the size of the universe. And it was just such a romantic, exciting post, and it got me really looking into what Gaia was all about. And so you are a treasure to the astronomy community, and I'm really glad to bring you back to the Victoria Center. And thank you for being part of our annual general meeting this year.
Thank you all for tolerating me. And Have a good general meeting. I'm going to conclude this broadcast day.
Very good. And it's late for him. He's 3 hours ahead. So